Hi, my name's Tim and I'll be walking you through a quick demo of how JITX helps speed up the hardware development cycle. In this example, an outdoor smart gate lock was specified during lunch on a napkin. The system needed to operate a servo motor attached to a gate lock with input from a push-button switch, a keypad, an NFC card and a web browser. It also needed to include a Hall effect sensor to detect when the gate had been opened, disabling the operation of the servo, as well as the ability to push gate status information to the web browser. Usually, prototyping begins with purchasing breakout boards and laying out the system on a breadboard with jumper wires. The breadboarding process often introduces connection issues which can be tricky to debug. Additionally, in this example, the headers of the NFC breakout board were designed to directly pair with an Arduino, so they didn't fit in the breadboard. Also, it was difficult to model the behavior the Hall effect sensor would have had on the gate. However, with JITX software, I was able to skip the breadboard directly to prototyping with PCBs. The platform only needs a few lines of input to generate a schematic and complete set of Gerber files for a PCB that replaces the breadboard. The input for this board simply involves declaring each peripheral and its parameters. Here we declare a keypad instance at location -640. Further down we also declare an LED at location 1533 with 0 degrees rotation. I then declare which side of the board I want the LED's resistor, that the drive is high, and specify the desired color green. Next I declare a power connector at location 2550 with rotation 180 degrees. Specify 2 pins and declare the power source will be 7.4 volts. JITX software will automatically include the necessary connections and components to support the input voltage. Then I declare the mounting holes with their locations and diameter, and finally I specify the shape and size of the board. JITX software then takes this input spec and deals with everything behind the scenes, taking care of placing all the necessary components and routing all the connections for interaction between the microcontroller and chosen peripherals. Rapidly generating a prototype PCB allowed me to test the system much closer to the final design. Having the PCB attached to the gate allowed me to verify the Hall effect sensor and confirm the absence of interference. I was also able to quickly identify mechanical considerations such as placement of the push-button switch. Since size was a concern in my design, with JITX software I was able to smash the breakout boards down to the chip level, reducing the form factor of the board by over 3 times. With only a few modifications to the input spec, JITX again takes care of everything behind the scenes, placing and routing the peripherals, the chips, and all their necessary components and connections. It also optimizes antenna placement to minimize insertion loss. With the duration of the hardware development cycle reduced, I was able to quickly move on to writing code and testing. Here I can see the system in action. First the push button unlocking the gate, then the NFC card unlocking the gate, and also locking the gate. Next, I can test the Hall effect sensor by opening the gate and verifying that the gate won't lock until it is closed again. Next, I open the web browser, check the status of the gate, and verify the Wi-Fi connection with the board. Finally, I test the keypad by inputting the correct code and waiting to see if the gate locks.